So this is activity 2, discovering interest formulas. So the goal of this activity is to try to better understand these 3 different formulas, the simple, compound, and continuous interest formulas. And so what we're trying to do is we're going to try to discover where these formulas come from, how they work, and how they're all connected. And so if you haven't figured this out now, all the activities we do are dialogue based. The point of them is to make sure everybody is involved in the activity. And there's also always a manipulative in each of these. The idea of the manipulative is to try to bring the mathematics to life. So like in the Pythagorean theorem, we had the 4 triangles, which we made into a square, and then we used that to prove the Pythagorean theorem. In this activity, what we have is phony money, and we try to use the phony money to try to better understand what these 3 formulas are actually saying. And so in this activity, there are 5 characters. The narrator, malfeasance is sort of like the evildoer, equanimity, the person who sort of brings balance to this situation, and simplicio, the person who's just really struggling, trying to understand, what's going on here, and then the banker. All right, so in Act 1, what happens is we meet malfeasance and simplicio. And malfeasance wants a loan for $1,000, and Simplicio says, "Okay, fine, but I want to know how much that you're going to pay me back each year." And malfeasance says, "Fine, no problem. I'm going to pay you back at simple interest rate of 5%, and I can fill out this table for you and tell you exactly how much I'm going to give you." So we know the formula, right? Future value equals present value times 1 plus IT, and so we can fill this out. And so what we have here is 1,000, left parenthesis, 1 plus 0.05, and after 1 year, we just put times 1, times 1, and we get our first answer of $1,050. So after 1 year, malfeasance will owe Simplicio $1,050. After 2 years, we can just hit second enter to pull up the last entry, and instead of a 1, we could put a 2. We get $1,100. And we can do it again for 3 years. Instead of a 2, we can put a 3. And we get $1,150. And we start to notice a pattern. Each year we're just adding 50. And so we can check just to make sure we did it right. Where we see a 3, we put the 4 for the 4th year. And we have $1,200. It's good. And then the last one we can just guess at, right, follow the trend, so $1,250. All right. So Simplicio says, this seems fine with me, but maybe you should explain how you actually found this $1,200 here. And so malfeasance says, sure, I've told you I was going to pay you 5% on $1,000. And so the way this works is you take 1,000, and to find 5% of it, you multiply 0.05, and you get $50. Right, so he says, so I would owe you after 4 years. I have $1,200 equals 1,000, and 4 years, and I take $50 times 4, and I get your answer. And Simplicio says that seems fair enough for me, but could you give me a formula to help me out? So he won't be tricked. And malfeasance says, sure. Look, here's what happened. You had $1,200. You let me borrow 1,000, and I paid you back 1,000 times 0.05, the $50, 4 times after 4 years. So I can use this to find a formula because I know this is the future value. This is called the present value, simple interest, and time. And I can write this in symbols then. So future value is FV, present value is PV, and I have present value here, PV here, simple interest rate here, and then finally the time there. And if we pull out what they have in common, then we get, so you look up here and they have a PV in common, so we pull out the PV, so we have FV. We pull out the PV, and then we get a 1 and an IT. This is always sort of a confusing step for students, but the idea is this. If I have A plus A times B, I can say, what do they have in common? Well, obviously they have an A in common, so I can pull out an A and write as A times 1 plus B. And that's exactly what we did here, but our A is PV. So they both have a PV in common. So we pull that out right here, and then we get a 1 there, and then an IT there. Right, so this is called the simple interest formula. And Simplicio says, terrific, I think we have a deal, malfeasance. And then equanimity comes in to sort of balance the situation and says, wait, there's a great inequality here. And so in Act 2, what we're going to do is we're going to discover the compound interest formula and how it is better than the simple interest formula, simple interest rate. And so Equanimity is going to try to explain this to Simplicio, and he basically says, look, each year you're making $50 off that $1,000, and that's great, but you're not making any more money off that $50. It's just sitting there. And what you really need to do is compound your interest, right? Make money off of your interest too. And so Simplicio is a little confused. So Equanimity goes through this sort of example, which we used our phony money. So the idea is you put down $1,000. So Equanimity says, look, you let this guy malfeasance borrow $1,000, and each year this $1,000 is going to generate 5% of it, so $50 extra for you. So after 1 year, you put down $150. $150 bill. After 2 years, you put down another $50 bill. After 3 years, you put down another $50 bill, and so on. Each year, the $1,000 is generating $50. And so you can figure out real simply, how much you have to pay back just by sort of watching the picture. After 1 year, it's an extra 50 on top of 1,000. After 2 years, it's not 150 but 2 50s. 3 years, 3 50s, 4 years, 4 50s, and so on. But the problem is that this pile right here is not doing any work at all. It's $1,000 that's generating all the extra money for you, and what you really want to happen is that this pile generate money for you also. And so Simplicio says, I kind of get the idea, but how do I get that pile to work for me? How do I compound my interest? And so over here, Equanimity tries to demonstrate how this actually works. Okay, so the way that this works is you start with a $1,000 loan, and after 1 year, you still have the $1,000, but you get an extra $50 because you sort of hit the $1,000, and out pops $50 in interest. All right, so this is the same as simple interest, but then when you compound the interest, you get a little bit more. So this is the little bit more that you're going to get, $2.50 after the second year. How does this work? Well, again, you have the $1,000 here, the original loan, and you hit this $1,000, right? And you get an extra 50. So now I have two 50s, and then not just hitting the 1,000, you also hit the 50, and you get 5% of it. So if you want to check in your calculator, right, you hit the $50 pile, and it's going to pop out 5% of it. So you take 5% of 50, and you see you get $2.50. Right, so each of these piles now generated money for you, so you got a little bit extra that you didn't have before. And we'll go through this again down here. So in this diagram, you're supposed to fill out the third year. So here's the first year. Right, so after the first year, right, you hit the 1,000 and it gives you an extra 50. Right, then the second year, what happens is you hit the 1,000 and you get an extra 50 on top of that. So now you have two 50s, and then you hit the $50 pile and it gives you an additional $2.50. And then in the third year, let's see what happens. Let's use a different color. Right, in the third year, you hit the 1,000 and you get an extra 50. So now I don't have just two 50s, I have three. So I have 50 times 3. And I also then hit the $50 pile, and there's two of these. All right, so I hit 150, 250, and they each give me $2.50. Plus I have the original $2.50, so now I have $2.50 times 3. Right, I got two of them from here and one from there. And I also hit the $2.50 pile, and I got to figure out what 5% of that is. So $2.50 times 5%, so 0.05, and it's $0.125, or we just round up and say 13 cents. All right, so all the piles are now working for me because I'm compounding my interest. And so down here I can fill in this table just by simply reading these off. So after the first year, I have $1,050. After the second year, I add all these up. So 1,000 plus 100 plus 250. So I have $1,102.50. And then the third year, I add all these up, 1,000, 150, $7.50, and 13 cents. And so on my calculator, I can add these up, and it'll tell me I get $1,157 and 63 cents. All right, so Simplicio says, "Oh, this is wonderful. All my piles are working for me. Can you find a formula that'll tell me exactly how much malfeasance has to pay me back if I do this. And equanimity says, sure. And he says, sure, we'll just have to do some simple math, and all of it. Simplicio's kind of upset by this. He doesn't like to do mathematics. It's so abstract. And equanimity says, oh, Simplicio, if I did not know any better, I would think you still thought the sun revolved around the earth. All right, so this is sort of the hint to where the character Simplicio actually comes from. It comes from a book written by Galileo Galilei in the 1600s. So if you know anything about Galileo, he's one of the people that is credited for proving that the Earth actually revolves around the sun. And so he writes this book in a dialogue form. So there are characters, and one of the characters is Simplicio from that book. All right, so he says, look, mathematics is not really abstract. It's really quite concrete and down to earth. And if you think about it in the right way, it becomes rather simple. And so what we had before is we started with 1,000, and then after 1 year, we had 1,050, and after 2 years, we had $1,102.50. If you think about what's going on here, what happens is that each pile is exactly 5% larger than the last. And what that means is that 1,050 can be found by taking 1,000 times 1 plus 0.05. And the next pile can be found by doing that again. So $1,102.50 is the same as 1,000 times 1 plus 1.05 times 1 plus 1.05. Right? Each time you're basically just multiplying by 1.05 to move here, then times 1.05 again to move there. And we can use this to find a formula. So if you look at this, right, this is my future value, this is my present value, and then this is my 1 plus the interest rate, 1 plus I, raised to the time, right? So this was a 1, and then this is going to be, actually, you can rewrite this as 1,000 if you want, times 1 plus 0.05 squared. Right, so there's actually a 1 here we normally don't write, and there's a square here, so it's raised to the time. And we can replace these words by the symbol. So this is FV, this is PV, and then this is an I, and then the time, of course, we use T, so raised to the T. And so there's the compound interest formula if you're compounding only once a year.